Welcome back. Happy day to my dear students and viewers. This is L. Nagarajan, working as assistant professor in the Department of Electrical and Electronics Engineering in MAM School of Engineering, Trichy, accredited by NAC, approved by AICT, New Delhi, affiliated to Anna University, Chennai. So today we are going to discuss about the types of amplifiers. What are the different types of amplifiers and why different types of amplifiers are used, where the amplifiers were exactly suits. Okay. So those things we are going to discuss now. Right. Now, types of amplifiers. Okay. So in these types of amplifiers, it is majorly classified as differential amplifier, operational amplifier, instrumentation amplifier, chopper amplifier, and isolation amplifier. Right. So first we are going to discuss about differential amplifier. But before going to discuss about this differential amplifier, let me give a brief pep talk about this. Characteristics of Opamp, that is operational amplifier. So characteristics of operational amplifier. First we can discuss about the voltage gain. The voltage gain should be infinity. Okay, the voltage gain should be infinity because even a small change in the input value must reflect at the output. Okay, there should not be any drop. Okay, there should not be any drop in the electrodes. So in order to do, the voltage gain should be reasonably high. So here this is up to 100 dB. Next one is bandwidth. Bandwidth is nothing but the band at which this operational amplifier performs the best. Okay. So as I said, the frequency varies from hertz to kilohertz. So the bandwidth is also varying. That is, but the bandwidth is already predetermined. Okay, for example, if you take ECG, the frequency is minimum. Okay. And at the same time, if we take EEG, the frequency is maximum. Okay. So depending upon the measurement, the bandwidth is to be considered. So, and one more thing, for each and every measuring techniques, the bandwidth is cannot be altered. Okay. That should be predetermined and pre-requested. Okay. If the device is connected in ECG, then the frequency is already preset and that it will operate by switching to that bandwidth. And input resistance. Okay, input resistance should be very high. Okay. We cannot make that one as 0. So the input resistance should be very high. Why it should be maintained high? That is, it should only if it is maintained high, then the leakage current will take diversion to some other minimum resistance loop. If our body and this electrode is very low, then obviously the leakage current will start flowing through our body. That should also be eliminated. So that is why the input resistance is too high. Then output resistance. The output resistance should be very low. Even it can be a 0 ohms. Why it should be a 0 ohm? Suppose in case our output resistance is high, then the biosignal which we obtained from our body has to travel, and it must be very much noted. Plus the characteristics of the current is to take the low resistance path. Suppose if our output resistance is very high, then obviously the output voltage or the output current that we have to measure at the output terminal will not be measured clearly due to the low resistance path compared to our output resistance. So that is why the output resistance should be very low, right? So common mode rejection ratio. Okay, the common mode rejection ratio for an ideal amplifier it should be infinity, but when it comes to a practical amplifier it is around 80 dB. The reason for this 80 dB is to minimize the EMI interference due to the AC circuit. Okay, what is the frequency of our AC circuit? 50 Hertz. Good. Next one, the offset voltage and current. Okay, the offset voltage and current should be 0 for an ideal amplifier, whereas in case of typical amplifier, it is from micro volts, few microvolts to few microamps. Okay, so this offset should be maintained. Okay, this offset will classify the exact the differentiation between the voltage, that is the biosignal, and the noise. If there is no offset, then it is very difficult for the students to measure the values. Next we are going to discuss about right leg driven ECG. What is this right leg driven ECG? Okay. So here we are utilizing the right leg of the human for measuring the ECG waveform. Okay, so the reason is, in many cases the reference electrode must be connected to the ground or to the right leg. Okay, in case of ECG, and in case of EEG this value is to be considered. Okay, so we will see this right leg driven ECG amplifier in the next class very clearly. Thank you.